Hello, and welcome to the Extralis training series, How to Calibrate in ECO. In this video, you'll learn how to zero calibrate, bump test, and span calibrate in ECO. Zero calibration introduces a gas that does not contain the sensor's target gas. It is used to give the sensor a clean atmosphere reference point. Zero air is typically 20.9% oxygen with a balanced nitrogen. Zero calibration of oxygen and carbon dioxide sensors requires the use of an inert gas such as 100% nitrogen. Bump testing is typically done to test the detector's output circuits. This would be for alarms, faults, and facility equipment such as emergency exhaust fans. Span calibration introduces a known quantity of the detector's target gas to provide a reference point. The detector will go into fault to signal that a calibration is due. The factory calibration due date can be set between 1 and 12 months, with a factory default setting of 6 months. Facility-specific environmental conditions can affect the calibration period time frame. If you want to change the calibration due date, the change needs to be done before the calibration process to reset the internal timer. When the unit is in calibration mode, the relay outputs of the ECO detector will not activate with gas applied. The 4 to 20 milliamp signal will read 2 milliamps, indicating the detector is in calibration mode. To begin, you'll need a bottle of zero gas, also known as zero air, a bottle of span gas that matches the detector you want to calibrate, a half liter a minute regulator with a 1/4 inch outer diameter tube. Mark the tube at approximately 4 millimeters to prevent overinsertion into the calibration port, which can damage the detector. To choose the proper span gas concentration, please refer to the ECO Product Guide, Appendix A. Note, toxic gases are referred to in parts per million, and flammable gases are referred to in percent lower flammable limit. Certain gases require special considerations. Always consult your span gas supplier for the proper equipment required for the gas you are using. A stainless steel regulator is required for reactive gases such as ammonia, hydrogen sulfide, nitrogen dioxide, and sulfur dioxide. When using reactive gases for calibration, use an inert tubing material such as Teflon. A nickel or chrome-plated brass regulator is suitable for flammable and non-reactive gases. You will also need the following. If you do not have it, you can download a current version of Extralis' VSC software from the Extralis website library or contact your local Extralis representative. The ECO's output can be connected to a number of different devices. Before bump testing or calibrating an ECO, alert the operations staff of the facility. When bump testing the ECO, its outputs will be live and will place the detector into alarm. It is important that no airflow is going through the ECO detector before calibration. Airflow through the ECO will dilute the test gas and prevent an accurate reading. The first step is to disable the VESDA detector. This can be done by logging into the VESDA with the VSC software. Once you log into the VESDA, go to Device, go to Standby, enter the user pin 111, and enter OK. The device now is in standby and the aspirator will stop. Next, close the ball valve above the ECO. If there is no ball valve, you must install one. This prevents external air from diluting the calibration gas. Now, connect the mini USB to the ECO. Open the VSC software and connect the USB cable to your laptop. The first time you do this, you must wait for the Windows drivers to load. Open the Connection Manager and then click Add. Select the ECO and then click Next. We will be using a USB connection. Confirm that you have the proper COM port, then select Next. Now click Finish. Now close the Connection Manager. Go back to Connections and open Connect and View. Click on Details and you'll see the connection list. Highlight the ECO, set as default, and then click OK. You should now be connecting to the ECO. Note the calibration fault shown in the event log. Ideally, the ECO detector should be calibrated before the calibration due fault occurs. Using a small flathead screwdriver, depress the compression ring and remove the calibration port plug. Open the regulator to ensure gas is flowing, then insert the tube into the ECO's calibration port. Be careful, inserting the tube too far into the calibration port will cause problems removing the tube and could damage the detector. With the zero gas running, go to the upper left-hand corner and expand the tree. Highlight the sensor, then go to Device, then click on Zero Calibrate. Enter the password 0999, then click OK. Confirm the correct gas concentration, then run the calibration. The calibration process should take between 1 and 2 minutes to complete. The calibration is now complete and you are assured the detector is reading a true 0. Now switch the regulator to the span gas cylinder. In our case, we're using methane at a 50% LFL concentration. At this point, we would bump test the detector before we span calibrate. Open the regulator and allow the gas to flow. As the gas is introduced, the detector goes into alarm. Confirm that alarm output circuits are functioning properly. Even though the detector is going into alarm, we still must span calibrate to clear the span calibration due fault. Now that the gas reading has stabilized, we can span calibrate the detector. Highlight the sensor. Go to Device, go to Span Calibration, confirm the calibration concentration, run the calibration. The calibration is now complete. It is important that when performing a calibration, you observe the gas reading before, during, and after the calibration. When the gas reading stabilizes, and if it's less than 60% of the test gas concentration being applied, this may indicate that airflow is diluting the test gas, the proper gas concentration is not reaching the detector, or the sensor has been desensitized since the last calibration. A stable gas reading above 140% of the test gas concentration being applied may indicate that the previous calibration was not performed properly. Finally, you must generate a calibration report. To obtain the updated calibration report, you first must log out of the detector. Then, log back on. Highlight the detector, then go to View. Go to Reports, then select Calibration Report. This will generate the calibration report. The top of the report contains detector-specific information. You must verify the span gas calibration level is within 10% of the gas applied. If not, you must recalibrate the detector. To save the calibration report, first you must install a print-to-PDF program on your computer. There are a number of free programs available on the internet. Select Print, then in your Print Manager, find the print-to-PDF program that you downloaded. Select, and then hit OK. Follow the instructions on the screen to save the report as a PDF. To review, it is mandatory that there is no airflow going through the ECO when calibrating. When span calibrating or performing a bump test, you must allow the gas concentration reading to stabilize before starting the process. The final calibration level must be within 10% of the gas applied. If outside this range, recalibration is required. When finished, open the ball valve above the ECO and re-enable the VESDA. The data from the ECO is saved on an SD card located in front of the mini USB port. Sometimes the card can become dislodged with connecting to the ECO's mini USB port. When finished, verify that the SD card is inserted by checking the detector's Details tab. The Details tab also provides other information on the status of the detector that can be used during commissioning and troubleshooting. Thank you for watching our video. If you have any further questions, please contact your local Extralis Technical Services representative.